Starting. All attendees are in listen-only mode.
And I decided it was going to...
Okay.
Good morning, good afternoon, good evening to people around the world. This is Martin Hubel, the venerable host of the DB2 Night Show. This is our 229th DB2 for LUW show, which is rather fantastic that we've been going now. I think this is our 12th season. And our special guest today is David Kalmuk of the IBM Toronto Lab. He's a senior technical staff member and master inventor. How are you today, David?
Not bad at all, Martin.
Well, that's great.
How are you doing?
Well, we're doing good here. We went from having snow a couple of days ago and a horrible windstorm at the beginning of the week to having a absolutely delightful fall day. It's almost like a day in September. It's so wonderful out there. So things are just absolutely wonderful, and we're looking forward to getting out and perhaps taking Mr. Charles there for his walk around the block. Charlie is getting near 16, and the number of days where I feel like taking him around the block, it has to be ideal weather because he's just a little guy. But let's move along and talk about things as we go. Here's our social media page. This is a show meant for you, the attendee. Here's our Twitter information, our LinkedIn group, and our replays are now available on YouTube. Kind of saying that all on every show just to let people know where we are. Our disclaimers, everything's being recorded. We have trademarks and they belong to the people that own them. We respect people's trademarks, and recordings and things will be made available later. As soon as I get the replay processed and get David's slides and all sorts of things like that, we'll be ready to go. Upcoming shows. Well, here's our agenda. Quick announcements and our studio audience polls. Shows next month. On December the 4th, if you're got any ZOS involvement, you'll want to hear Dan Luxtetich. He'll be speaking on index performance recommendations. That's always a popular topic, and Dan is the man in terms of many things to do with DB2, so you want to hear that show. And to finish off this calendar year, we're ending on a strong note by having machine learning and AI from Sheikh Kader from the IBM Toronto Lab. And that'll be a great show. And stay tuned. I'm in the midst of setting up the schedule for the new year from January to June. I'll post those shows as soon as I've got them finalized. Certainly I'll have them lined up by the December show, so I'll be able to announce the January show and so forth. As always, DBI is our founding sponsor of the DB2 Night Show, and they make available a demo available at the link below. If you're interested in DB2 LUW performance, it's certainly worth your time to go through and watch that demo. Also, as this is a DB2 LUW show, I'll be showing a brief video in the middle of your presentation, Dave. If you've got a good break point, just let me know, and I will show a video that DBI has put together. It's about 2 minutes long that shows real-time monitoring today. And as always with the DB2 Night Show, our studio audience attendees get a chance to win a prize, and it's an Amazon gift certificate. Last show's winner was Sandra Thompson of One Main Financial. And as always, thanks to our sponsors, DBI, and yours truly, Martin Hubel Consulting. And now we're into doing our studio audience polls, so let me bring those up. And first one is our standard poll. Which versions of DB2 are you currently running? I've shortened this up. As we get a new version in, we have DB2 11.5 right now. And actually, DB2 11.5.5 is just out, and that's some new functional things in there. I don't expect anybody would be running it yet because the announcements are just happening. but there it is. And we've got some people voting on that. So we'll close that and share the results. 100% are on 11.1 today. Okay, moving along. Which of the following deployments are people using? And I believe this is check as many as you have. Whether people are going containerized yet. I must admit, personally, maybe I'm an old guy, but local installations without containers is still my favorite way of doing things. I'm going to have to get more cloud-oriented, I guess, at some point in the future. Let's close that and share that result. Everybody today is 100% local installation, people after my own heart, so to speak. Next question. What are your primary uses of DB2? I should have put OLTP and HTAP together, but OLTP is the old term. HTAP is hybrid transaction analytic processing, which is the new term. And I also put data warehouse and data analytics separate as well. Data warehouse is being the old way of doing things, and data analytics being the new way. You know, Dave, we should share the fact that you and I have a shared history. We went to the exact same high school and the same university. We went to Humberside Collegiate here in Toronto, and then we went on to University of Toronto. That's I've always enjoyed that as a fun fact, that we could both, two people from the same roots could be doing the same thing. All right, I think we're going to leave it there in terms of voting and move along. And this next question is really gets down to the point, are you using DB2 Blue for anything? I was thinking about this the other day. We went through a period 4 or 5 years ago where the only thing IBM would talk about was column organized tables in DB2 Blue, and it looked like they'd take over the world. And lately, there hasn't really been that much conversation about it. So I'm just interested in seeing what we have there in terms of people using it. Looks right now we've got still an awful lot of row organized tables out there, and I'm sure people are using the column organized stuff as needed. I look on it the same way as when multidimensional clustering came out, MDC tables. They were really hot, and then after a while, people learned where to use them, and they get used where they're appropriate in many organizations now. So let's close that off. We'll share that result. Got everybody still using row organized tables, and some column organized tables are coming into play. And the last question we have before we get on to your presentation is about the topic itself. And I be interested to see if this one you only get one choice in terms of whether or not you're using it, testing it, but you're not using it, but you will, and no plans, and what is it? So this one, we'll see what people say on this. And just waiting a little longer, but I don't know if we're getting any more votes at this point. So let's close that off and share their results. And gee, nobody's excited about this topic today. That's not good news. I know you're going to tell us some good things there, Dave. So let's move along, and we'll close that. That's all closed off. So we'll turn it over to you, Dave, and let me make you the presenter.
Okay.
And I think we're going to have an awful lot of people that will be wanting to hear the replay of this. even if we don't have a large studio audience today, we'll still have people on replay. So, and as I mentioned earlier, I can see your mouse. Don't know if you need to click something to show your other screen or something. You were working earlier.
Yeah, let me see what's going on here.
There you go. Just like
you can
that.
see that one?
Yep.
Okay, let me go to presenter mode. Can you still see it?
Nope.
Oh,
Is it,
okay. Well, we can fix that.
There seems to be another screen that isn't plugged in or not showing, or if you can get it to present on that screen, I think that's the answer we need.
Let me see what I can do here. So, showing PowerPoint. I do this. I'm gonna try one more time, and if not,
nope.
Okay, so maybe I'm gonna stop.
It's not showing there. We're in the same set. Okay. There we go. You're there now. Perfect.
Okay.
Okay, what I'm going to do, I'll be monitoring the Q&A, the question queue. We have a question tool and GoToWebinar, and I'll be watching for anything coming through on that, but I'll mute myself so you won't get any spurious background noise.
Okay.
All right.
All right, so I assume I'm good to go?
Yes, you are.
Okay, so topic we got for today that I'm going to talk to you about is our adaptive workload management in DB2. So our new generation of workload manager, which we're been in the process of building out, and we just rolled out for the DB2 on-prem customer base in 11.5.4. And what I'm going to do today, or my goal, is to give you an overview of the technology, what it's for, why it's interesting, why it matters to you. And as always, I like to touch on a little bit of tuning and best practices and how to use it as well, to at least give you an entry point if and when you want to start using the technology and features. So let me see if I can get there we go. So what I'm going to do, a couple of things. I'm going to spend a little bit just kind of putting some framing around concurrency and workload management in the database context to kind of lay out how we think about workload management, which will be helpful for understanding the rest of how I present things. I'm going to talk to you guys about the actual adaptive workload management technology, why it's interesting, what it is. Then we'll get into some of the core use cases around adaptive workload management, which is essentially the prioritization and management of resources across workloads you define in your system. And then we'll talk a little bit about monitoring and tuning the adaptive workload manager, so that I give you some concrete things that you can take away and use to get started when you're working with this in your own environment. So let me jump right in. And start just talking a little bit about concurrency and data in your database and workload management in general. And I am going to focus or bias towards data warehousing systems. And the reason for this is that oftentimes or traditionally, we see workload management being a lot more prevalent in the data warehousing space. And that is mainly because of the workload characteristics, particularly the fact that these systems run more complex, more resource demanding queries. And when you have those in a mix, especially with the column store, you need some form of workload management in place if for nothing else, but to just keep your system stable and prevent the workload from overrunning things and causing some sort of exhaustion and failure. And when I'm talking about modern data warehousing here, I'm really just talking about the general trend in workloads that we see out in the field, which essentially, if I were to boil it down, is more complex all the time. So what I've been seeing personally, and I think although I won't claim to be an expert in the field of database administration or management, we're definitely seeing, that the trend is definitely not towards things getting simpler, especially on big scale warehousing systems. You're seeing workloads that consist of all kinds of things, everything from small point queries, transactional type activity, to interactive reporting, reports where you're expecting instant responses, to heavier, longer processing analytics, continuous data ingest, all trying to run at the same time, all trying to run, often trying to run 24/7 by 365. So these are big systems, and the users of them typically expect a lot out of them. Even the smaller scale ones, you know, the trend is definitely towards more concurrency, trying to squeeze more out of these systems. So there aren't a lot of these systems where the workload is very uniform and very simple. And of course, the user demand is, I want to be able to run concurrency on these systems, and I want the system to be stable and run well. And what that means internally is we need an effective workload management mechanism, even if the goal is not to explicitly control the workload, but just to keep the system stable. We need a good workload manager in these systems to run them well. So the way I tend to characterize the goals of workload management in a database system, just in general, is along three axes. The first being a very basic goal of ensuring system stability and responsiveness when you're hammering the system with many connections and many concurrent jobs. So the goal there is simply, you know, let the workload, don't allow the workload to overwhelm the system and overcommit it so that things fail, but manage the workload in such a way that the system is well utilized and you're getting all the performance that you can out of it. And then a secondary goal related to that is having enough intelligence in the scheduling of jobs that you ensure fairness and appropriate responsiveness. And that's really about making sure the system doesn't do silly things like take a reporting query that's going to run in a second and queue it behind a heavy batch analytics job that might run for 15 minutes. So it's about managing the workload to the system capacity and ensuring that you've got adequate responsiveness and fairness in different jobs competing for resources. So if that's a sort of table stakes goal, the second goal of workload management is the ability to actually have the user have control over workload prioritization and isolation. So this would be more, I don't just want the system to run well and stay stable. I want to actually have some control over how I carve up the resources between different workloads, because I have different categories of work, and I want to potentially isolate or bias towards some of them. So this is all about being able to classify the work that you're running on the system into groups that you define and controlling how much resource those groups get. And then complementing all of this, what I call workload governance and monitoring. I mean, monitoring is critical for every element of this, because especially if you are taking control and saying, you know, I'm going to put my reports over here and I'm going to give them this much resource so that they can run in a reliable way, you need to be able to monitor every aspect of that to understand what's actually happening. I gave it this much resource, how much is it actually using? Am I getting the performance I need? So monitoring is kind of built in through all of this. But as part and parcel of, I guess, the flip side of monitoring is once you have metrics around what your jobs are doing, what the resources are that they're consuming, we also want to give you capabilities to define rules on the workloads as well. And this is around being able to set boundaries, because now if you start to actually manage your workload and define what they are and what they can do, you have the ability then to also put some constraints on them. If you have a reporting workload that's supposed to generally be doing, you know, quick queries that are going to render web pages, you know something about that. And you can start to put rules around it to say things like, well, you know, if I ever see a query coming in from this workload that's going to be churning through, you know, hundreds of thousands to millions to billions of rows, that's not expected. I don't want, you know, a job coming from that workload to do that, because that's going to churn my system and consume resources, and I know it's not supposed to do that. So the governance part is being able to define thresholds and rules which will identify outlier queries, and you can choose to kick them out rather than letting them run and consume resources on your system. So it's an extra element of control to keep the system running well. So those are the goals. Let's talk a little bit about DB2's workload manager capabilities. And these have been around for quite a while now. I believe, if I'm not mistaken, it was DB2 9.5 when we first released the workload manager. I could be wrong. It could even have been 9.1, but I thought it was 9.5. But what we came up with in the initial workload manager was really, I'd characterize it as a highly customizable set of tools for doing workload management. It was really a framework with a whole bunch of capabilities that you could use to kind of build your own workload management configuration. And we were definitely aware of that. It was very open-ended. So the other thing we did is to provide a very comprehensive best practices to give you kind of a prescriptive template. You know, start here with this, and then you can make adjustments and tune this basic template that we give you in order to work for your workload. And you know, this little, you know, my characterization here is we gave you the workload manager menu. So on the menu, we had all the different things you needed to build your workload management configuration. Everything from classification to prioritization to admission control, and then, you know, with a kind of prescription, so say here's what you do. You know, you're going to want a bun, you're going to want a burger patty, and then you can choose these other things to get your configuration running well. And if you go through the process, you know, and get it working well, it can be quite effective and efficient. But it's certainly not a simple set of tasks. And you know, it was everything from a fair bit of manual setup to applying the template, and then a lot of the elements of traditional running the workload manager in DB2 was tuning and retuning and monitoring. And to really boil it down and simplify it, what you ended up doing was adjusting timer-on ranges. So we would use timer-ons as a measure of query complexity to try to segment queries into different categories or lanes almost. I like to think of it as lanes on a highway. So you sort of say, I've got this workload coming in, all kinds of different jobs, but I'm going to find a way to segment them into groups like the small, the medium, the large jobs. And then I'm going to try to ensure that each one of those has a certain entitlement of resources on the database. And in so doing, I get fair sharing and fair behavior between those types of jobs. So that means that there's a lane for the fastest jobs, and only the fastest jobs consume the resources in that lane. So that means that I can move that category of jobs through the system quickly. So if a small job ends up waiting for resources, it's only waiting behind other small jobs, and we keep the throughput going quickly. And similar thing for the bigger lanes. You know, the big jobs will come through. They'll come through more slowly. They're doing a lot heavier work, but they don't get in and interfere with the small jobs. So that's all nice and good, but what you would end up doing is trying to adjust the timer on ranges based on your workload to get a nice lane division, and then you would end up applying the major point of control in traditional WLM is the concurrency threshold. It's really a concurrency limit that says, hey, you know, in this lane, I'm only going to let, you know, N jobs in. So you know, once you hit N, other jobs have to wait their turn. But what is N? So a lot of the work in tuning the workload manager is figuring out those limits, and then over time maintaining that so that the workload changes, you're adjusting those limits. And it, you know, tended to be pretty labor intensive. And the reason for this, so I mean, you know, zeroing in on those two things, cost ranges and concurrency limits, I mean, these are basically they're pretty low level controls. So, you know, our goal may have been, hey, we want this category to only consume this much resource. But the knob we give you is a concurrency limit to say, okay, you know, 3 queries, 10 queries, 50 queries. And you know, it was kind of left to the DBA to figure out how to tune that to get the desired resource allocation. And if you look out in the industry at the different workload management solutions, you know, this is a very common approach, and you'll see names. I mean, we have concurrency thresholds in DB2. You'll see names like throttles and slots and queues and memory limits, and they're, you know, but they're all similar things. They're putting some sort of fixed definition on concurrency at some granularity, and then having you figure out what that number should be. And the reason that's been fairly common is it's a very straightforward and simple thing to implement in the database engine. It's just, you know, a count. I'm going to let 10 jobs in. So how many jobs do I have in right now? If I don't have 10 yet, I can let more in. If I'm at 10, you know, I got to hold the job until somebody leaves the system. But it kind of pushes some of the heavier work on figuring out what the limits are and what you need to run properly on the DBA, which is not good. So this is the Adaptive Workload Manager kind of came out of that challenge, and part of what was driving it is at the time we started working on the technology, we were pushing into cloud services with DB2 Warehouse on Cloud, DB2 on Cloud. We were working on the IBM Integrated Analytics System, the Sailfish appliance, and it was becoming very clear that we needed to make this easier. In those contexts, there's the expectation, especially in those sort of prepackaged form factors like a SaaS service. You don't go into your Gmail and configure workload management so that you can check your email without crashing. So we knew we needed something that was going to be basically automatic, zero tuning, that would take care of things. And that progression of more complex analytic workloads and I guess technologies like the column store. So we introduced column store a number of years back to accelerate analytic workloads, but column store in terms of workload management certainly does not make the job easier, because column store, the column store is heavier on memory by design. It's trying to do a lot of stuff in parallel, but it started to shift the pressure point on the database system, at least on the warehousing side, from CPU, which is a little more forgiving if you let a little too much in or a little not quite enough, to memory, which is not forgiving at all. If you exhaust the memory on your system, there's no sort of gradual decline in performance. Once you're out of memory, you're out of memory, and you can't continue processing if you needed that memory. So because of that, we wanted to get off of the workload management configurations based on fixed limits and get something a lot more automated. And just this quick picture here kind of illustrates the problem. This is laying out a model again where we're saying out of the box, this is not an actual configuration. This is just an example to characterize things. But I've got my system. I'm going to I want to carve up the workload management into a couple of different lanes so that I can separate my smallest from my biggest jobs. And by apportioning a certain amount of resources to each one, I get fair share behavior on the system, and things will run well. So traditionally, the problem was, well, okay, that's great. What time run costs do I need, and what should my concurrency limits be to hit that target? So the Adaptive Workload Manager. Oh, just one more example. I mean, just to drive the point home, the best intentions with a fixed configuration still leave you vulnerable, because what can happen is you tune for a certain workload, making certain assumptions about the size of jobs and what's going to happen, and then something different happens in production. You get a workload with massively bigger jobs, and you get pooched because your concurrency limits were too high and you let too many of those jobs in. So that's a maybe a little bit long preamble, but I think it helps to set the stage of why we did Adaptive Workload Management and what it is. And what the Adaptive Workload Manager is, it's really, the concept is really simple. It's just the idea that we're going to manage the admission of jobs into the system based on the actual resources they require instead of fixed limits. And doing that is pretty powerful, because what it means is, what concurrency level should we run at? Well, the concurrency is based on how many jobs we can fit. So if you're running bigger jobs, we are running lower concurrency. If you're running smaller jobs, we can put more of them in the system. So that allows us to make a lot more efficient use of the system resources, and it avoids these problems with workload changes causing problems in a static configuration, because when you're doing admission based on resources, you're implicitly adapting to the jobs we're putting in the system. So just to get a little more concrete, what the Adaptive Workload Manager looks at when we're submitting jobs to the system are two things for admission and scheduling of jobs. The first is the query sort memory requirements. So this is your S-heap thresh shared, your sort memory on the database. It's essentially the working memory that we use to do all the number crunching in the database. So, you're doing an aggregation, you're doing a join, you're doing sorting. The memory that we use to buffer and transform the data to do that is the sort memory. So that's the memory the query is really working with, as opposed to the buffer pool where we've actually just cached the table data from disk for fast access. And then the second thing we look at is the number of parallel threads that we're going to be running in that query for your processing. And those two things allow us to manage the memory consumption and also the load on CPUs. And that, in a nutshell, is the difference with the Adaptive Workload Manager. And I'm going to get into what that means. Now, in terms of availability, we introduced this initially on the container offerings. So Warehouse on Cloud, DB2 Warehouse on-prem deploy, and IaaS, because that was where the strongest need was initially. But of course, the plan was always to bring this to DB2 in general. So in 11.5.4, we took the first step towards that by allowing making the Adaptive Workload Manager available for configurations that have DB2 workload equals analytics. So we started with columnar because columnar was the bigger pain point due to its heavy memory design. But also because it's a little bit narrower in terms of the configuration. There are some restrictions with columnar, and that gave us a window to do an incremental delivery of this. Now, getting into next year, we're going to drop this limit, and we're going to have this available for any configuration of DB2. So that's definitely our plan, but the first rev was for more oriented towards column store configurations. So just to restate the goals, the real goal with the Adaptive Workload Management, and I'm going to differentiate, I should call it one distinction here. The Adaptive Workload Manager, when people think of workload management, they're often thinking about, or I think they are thinking about, the ability to control and prioritize workloads. But I would say there's two goals to the Adaptive Workload Manager. The first one is just out of the box, manage the system, keep it stable, and have it behave well, and do that with no tuning. And the secondary goal, or the second goal, is if you explicitly want to configure your workload management to do certain things, to carve up resources, then we want to make that a lot easier. So circling back to these goals, we wanted to get to true automatic workload management out of the box with no tuning. We wanted to get rid of the need to configure and tune and maintain fixed concurrency limits, and ultimately get better stability and performance, and make things a lot simpler for the DBA, more stable in the database system, easier for the DBA, better experience for the end users of the system. And just to contrast, so I'm going to try to hold back, to not bias to go too deep. I mean, I love the bits and bolts and nuts and bolts of the technology, because that's my profession. But if I were to try to abstract it at a higher level, the key difference with the Adaptive Workload Manager in terms of how it works in practice and the more traditional workload manager, which is working on a static configuration, the traditional workload manager is basically following some static rules. You've got a set of timer on ranges to figure out which service class, which group to map your queries to, and then you've got static concurrency limits on those service classes. And it's an open-ended mechanism with no feedback. You set that configuration, database manager follows the rules, and hopefully you get a good result. The Adaptive Workload Manager, on the other hand, is very much a closed loop with continuous feedback. So I kind of glossed over this. A natural question to ask would be, well, this sounds like a sensible thing to do. Why wouldn't you have done that from the start? And the reason is that while it makes the job easier on the customer and the user of the database, it certainly makes the technology job harder in the engine. Because what you're doing essentially is you're trying to predict the resource requirements of incoming queries. And that prediction obviously is fallible, especially when you've never seen the query before and we're relying on the optimizer to build up an estimate for us of how much memory the query is going to consume. A lot of the complexity and the secret sauce in the Adaptive Workload Manager is how we deal with that uncertainty to deliver stable behavior. So at the risk of going a little bit, into a little bit of gory detail, a lot of what makes the Adaptive Workload Manager work is a continuous feedback from the system. The Workload Manager has a view of what it thinks is happening based on the jobs it's scheduled and what it thought they were going to consume. We've got a constant feedback loop where the Workload Manager is monitoring the actual behavior in the database and seeing where there are any divergences between what's actually happening and what it thought was going to happen. And then based on that, it is adjusting and taking action to proactively address any discrepancies. So if we see that we're consistently underestimating the size of jobs that are coming in, the Workload Manager will start adjusting the estimates to be a little more, to fatten them up a bit so that we can, so that it brings its view back in sync with what's actually happening on the system. And ultimately, the goal there is to be as accurate as possible so that we are filling the system up well, but not overcommitting it. And there's a lot of nuances into how that works, which I won't get into, but we've got this constant feedback mechanism. We've got some proactive and preemptive behaviors that the Workload Manager will do based on what's happening on the system so that it can get ahead of things like, especially underestimation. You don't want to, underestimate consistently and let too much work in. So we have mechanisms that will kick in fairly aggressively to say, hey, we're starting to see that that globally we've been underestimating the size of jobs. We'll take some action on future jobs to ensure that we iron that out. But we're also doing things like caching information on any jobs that we've seen before, which can result in a substantially better estimate the next time we see that job. So we've got this sort of dynamic mechanism that's constantly looking at resources, and that's allowing us to kind of implicitly derive the concurrency limits we're supposed to be using. Similarly, for the mapping into different categories, we're looking at the runtimes of queries instead of the time run cost. So we're actually saying, if we want to group short queries together, let's figure out what the runtime of the query is going to be and group based on that, rather than using a time run and trying to figure out what the runtime might be. So all of that is to say, a lot of the magic with Adaptive WLM is under the hood, and how we make the the external mechanism, which is simpler, work. Just looking at the time, Martin, this might be a good time to take a break if you wanted to do an interlude.
Sure. Let me just fire this up and we'll get underway. I just need to take control of the screen back. Make myself a presenter here. And then I will show my screen. Hopefully you're seeing a video panel there. And now I'll just hit play and away we go.
Hi everyone, thank you for watching the DB2 Night Show. Today I'm going to show you the new DBI Web Suite tool. I'm going to show you the part about real-time monitoring of the database. I'm going to go right here and click on real-time. And real-time shows you first a dashboard where you can see important metrics about your database. These are real-time metrics that run. Here you can see I can run it every 10 seconds or change it to 20, 30 seconds, whatever, and I will see when the next update is going to be. Here I see memory utilization, free and used, CPU utilization, log utilization on my buffer pool, hit ratios, rows read versus rows returned, log time, and so on. I can take any of those metrics and click on them, and then I can go and look at the actual details. I can look at the top CPU, top IO, top execution. I can look and see all the statements that are running at this time on the database. I can also sort them by different metrics and so on, and see all of them listed. I can see the logs, and if I have any, I can clear the logs, buffer pools. I look also at the configuration parameters for the database. I can see them all here. I can very quickly search for any parameter that I want. I can look at the manager configurations, also parameters. I can look at the registry settings. And finally, I can look at the actual system resources that are running and any information I get. I can always keep this open and watch out for any problems or any issues that are happening currently in the database. That's it for today. Thank you for watching.
Okay, Dave, thanks so much. Thanks for watching, folks, and I'll pass it back to you again. You just need to click that you're the presenter, and we see your screen again.
Okay.
Thanks so much.
All right. Okay, so now what I want to do is transition a little bit. So up to this point, I've kind of talked concepts. Let me just make sure, Martin, can you hear me? I want to make sure I'm not on mute.
You're great. I can hear you just fine.
Okay.
Thanks.
Perfect. So the reason that was a good interlude point is because up to now, I was covering kind of concepts and some of the engine technology behind Adaptive Workload Manager and the goals, but I want to shift gears a bit now into the actual nuts and bolts of how you use it. So obviously I talked a little bit about out of the box and the goal of automated workload management, which basically means, it's there and it does what it's supposed to and you don't worry about it. But the other big use case in workload management is the ability to control and prioritize your work. And a major goal of the Adaptive Workload Manager was to substantially simplify this process. And we really came into this with a model in mind, which was, wouldn't it be nice if rather than doing the complex task of, configuring a service class and subclasses and work action sets and timer-ons and concurrency limits, all to be able to divide up the resources on your system. Wouldn't it be nice if instead what you did was you defined a service class. If you wanted to split resources, you defined a service class. So I said, here's my bucket. I'm going to tell you what type of workload it's going to be roughly. Is it going to be a more homogeneous sort of interactive or batch workload, or is it going to be a mix of all kinds of jobs? And then I tell you the amount of resources I want that service class to have, what proportion of the database resources it should have, and whether I want a hard or soft enforcement of that limit, and then that's it. The system figures it out for me. So, that the idea being, let's split the system 50-50 between two categories of work, reports and ETL, for example. And that's what I want to tell the system, and then the system figures it out. And that is essentially what we built with the Adaptive Workload Manager. So that's what we built out. And to provide a little more concrete example of how this looks, if you assume a sample use case here, I'm going to do two things in this example. I'm going to take the database and I'm going to put half the resources to just general work, and I can put the other half of the resources to two specific workloads. I'm going to take that second half of the system and split it 50-50 between a high priority reporting workload that I want to have 25% of the system, and another 25% that I want to put towards ETL. And that would be, you would do this if you want to ensure a certain dedicated amount of resources for these categories so that you can achieve a particular SLA or isolate for reliable performance. And the way I would do this, to these three tiers, I would create three service classes. In this example, I'm doing service class high pri, ETL, and general. I'm going to give it a resource share. So the way we do the resource allocation is with the concept of a share. It's just a weighting it's a unit list weighting, and the relevant control is basically the relative weighting between them. So in this example, if I do 300 and 300 and 600, that's 1,200 shares total, and the proportion of resources that represents would be the service class's share versus the total. So general has 600 out of 1,200, that's 50%. The reason we do it this way is that it prevents you from, if we did it as a percentage, you get into funky business where if you're trying to change or increase the share of a service class, you would have to reconfigure all the other ones on your system so it adds up to 100. By doing a unitless share, it's just the relative weighting that determines what your share of the system is, and it avoids the need for you to have to constantly have everything add up to 100. But it does effectively boil down to a percentage division of the system. So Coming back to that, I define my service class, I assign the share of resources I want to it, and I give a hint on the workload type. And we'll talk about that a bit more in a bit, but then that's my definition. So now I've divided up the system in the way I want. The other thing you need to do, we have the concept of a workload, which is your mapping construct. So we have these service class buckets, but now you need to tell the system how we categorize incoming sessions and who goes where. So the workload allows us to do this. And in this case, just using a simple mapping based on the session user for incoming sessions to identify what application we're dealing with, group it into the right workload, and then the workloads are what map you to the service classes. So here I'm assuming, and I won't get into this in this session, but you can map on a whole bunch of different attributes. Session user is just a common one. So here I'm going to say, on my system, anyone who's coming in as EDW reports as a reporting user, they go into the high priority reporting service class. So you set up your workloads, you alter the, in this case, I wanted general to be a catch-all, so I altered the sysdefault user workload to point to general. I should note as a gory detail, and maybe I should have included it here, you've always have to grant usage on the workloads. If you don't grant usage to public or to the appropriate users, they won't map to the workloads. So that's just a tip if anyone's actually trying this. But again, essentially what you're doing is create the service class definitions, create the workloads for mapping, and you're good to go. And just to contrast what that means, so here, the way you would set this up in traditional WLM, you're still trying to do the same thing. So you would start with your two service superclasses. That's your division between your two main workloads. But then instead of just defining a resource share, what you would be doing is you would also have to say, okay, I'm going to be running a mixed workload in the service class, so I better put some subclasses in there. And I need a work action set to do the mapping between subclasses, and that'll be based on timer on ranges. So I'm going to have to tune those. And then for admission control, I'm going to put a concurrency limit on each one of the subclasses. I'll have to figure out what that is in order to get a good division between those subclasses, so there's fairness. And I've also got to worry about the overall concurrency between the two service classes and make sure that all works out so that I get the division I want. And if the workload changes over time, I may need to adjust that. So a lot of layers there. But with the Adaptive Workload Manager, we essentially take away all of that complexity, and you're essentially working at that top level. Give me, this example doesn't exactly correspond to the one I showed 2 slides earlier, but same spirit. If I want to split the system 70-30 between 2 service classes, the Adaptive Workload Manager, you just define that share weighting. 2 service classes, 70-30. I'll tell you what type of workload it is. That workload type attribute, what it actually does is it gives us a hint of what the workload is, and we pre-configure the subclasses for you. So if it's a mixed workload, we'll give you a couple of different subclasses to separate small and medium and large jobs. And we can, because we're dealing in resource shares and not fixed concurrency limits, we can set up a balance that's going to work for the vast majority of cases. So we can take away that complexity from you and make the configuration of this very simple from an external perspective. So that's really the model of prioritization with Adaptive WLM. Again, the goal is to substantially simplify things, not just in terms of how you set it up, but also how you need to maintain it. Because with the Adaptive Workload Manager, we're constantly working to hit those targets. So if the workload changes, we change the scheduling behavior. You don't have to go back and retune accordingly. Okay, a few more details on that. So I mentioned the workload type. That's the thing we use to pre-configure a template for a particular workload. And again, just to reiterate, mixed is where we would define multiple subclasses with different categories of queries, because we know you're going to be running maybe very small and medium and large jobs. Batch or interactive, we're expecting a more homogeneous workload, so we're not going to have a lot of lanes in the highway, so to speak. But we will bias the behavior. For interactive, we bias the behavior to be a little bit more sensitive to latency. So we will bias to let shorter running jobs run a little sooner than jobs that run a little longer, under the assumption that if you have a job that's going to run 2 seconds and we make that wait for a millisecond, We're not too concerned. If you have a job that runs in half a millisecond, we make it wait for a couple of milliseconds. That's a big proportional delay. So we'll do things like that. The shares I mentioned, I want to talk briefly about soft versus hard. So in addition to doing an allocation of resources, we have this concept of soft and hard. It's very much like the CPU shares, if you're familiar with those. But the idea there is we've got a target. Let's say we split the system 50-50 between two groups. Then the question becomes, if the system isn't fully utilized, if there's spare capacity, what do we do? Do we allow a service class to go over its entitlement temporarily and tap that resource? Or do we strictly lock it down and say, no, you had 50%, you get 50%. It doesn't matter if the other 50% is free, you're limited to 50%. And that's the difference between the soft and hard. Then last but not least, we do have the concept of a minimum resource share percent. And the idea behind that is simply you've got this share division, especially if you're using soft allocations, we are allowing people to go over their entitlement when there's spare capacity. But then the question might come down to, you sort of say, okay, I want that from an efficiency perspective, but I've got this workload and it's very latency sensitive. And I don't want the other workload temporarily going over its entitlement and putting some big jobs in the system that run for a long time, and then I can't get that back when I need it, and my small job waits. So in that case, you can use a minimum resource share percent to say, for that very latency sensitive workload, I'm going to put a minimum, and it's actually going to hold on to a percentage of its resources all the time, so that it's always got some amount of resource to be able to quickly execute very short jobs if they come in. So that's where the minimum comes in. A few more goodies got to talk about, and then we will move on to a little bit of the tuning and monitoring to wrap things up. So a couple of complementary things that we've introduced along with the Adaptive Workload Manager. So DB2 Thresholds, I was mentioning earlier in the session, these are the rules that you can put in place to sort of identify and take action on rogue queries. Traditionally, these have been things like rows read, CPU consumption, execution time, where you can say, this is an interactive workload. If I see any query that's trying to process billions of rows, that's bogus. Somebody's done something bad, and I want to kick that guy out and not let him eat up the resources on my system. Well, a very important thing to worry about with the Adaptive Workload Manager is memory consumption. Because we're doing our apportionment and scheduling based on memory in a large part, what you don't want is a big job that has an excessive memory demand coming in. There's some type of rogue query that can come in and consume a lot of memory and really jam up the system. So we've introduced a threshold on sort memory that you can set. And basically what it's aimed to do is you can put that in place to say any job that wants some unreasonable amount of memory. For example, single job that wants more than 25% of my overall working memory on the system, I want to detect that guy and kick him out. I would rather investigate the failure of that query because we booted it with a threshold and figure out why it's demanding such a large amount of memory, than let that guy in and actually potentially have it jam up the system. So we've introduced that threshold. It's got an interesting variation. You can define it as a straightforward threshold where you say, hey, over 25%, any job that does that, out. You can also do a softer definition where you say, I'm going to kick out any job that demands more than a certain percentage of the resources on its own, but I'm only going to do that if it ends up blocking other jobs. So you can, in that way, say, I'm going to protect the system, but if there's room for the job to run and he's not hurting anybody, it can go through. Other thing we've done is we've introduced the concept of a session priority. So this is, it is what it sounds like. It's the idea that you can take a connection, an individual connection, or a workload and say, I want the jobs in this workload to run with a higher priority than the other jobs. So you can set the priority by default is medium on everything. And you can use this to set a priority as high, low, or critical, which is even higher than high. And what it really does, so if you assume you've carved up your system into service classes and you've apportioned resources in that way, the goal with the session priority primarily is to say, hey, I've given 60% of my system to reports, and that's great. But I've got a very critical user, and when he comes in, he's got to be able to run the report, as soon as possible. And I don't want to define more service classes to try to deal with that. So with this, what you can do is you can take that user and identify him via workload, and give him a high priority. And what that means is when he comes into that reporting service class to run, he's going to get to jump the queue essentially and run as soon as possible. And it makes the configuration a lot simpler because you're not starting to worry about trying to divide up your reporting resource allocation into, well, let's take some of that and assign it to this special user, and then I've got more service classes, and what do I do if that user's not in there? This makes that job a lot simpler. I'm going to skip saying much on short query bypass because I want to quickly touch on a few of the monitoring things. The main thing to know with the short query bypass is that we do have some smarts that if we have a very, very short, very low impact query running in the system, we're going to actually let it bypass the admission control, and we do that because sub-second jobs may actually be impacted by us, going to ask permission to run. So we have a mechanism to bypass that. As DBAs, you should know that we have the sysdefault administrator workload, and if you set your workload to sysdefault ADM workload, that also has the effect of allowing all your work to bypass the queues. So when you're the admin, you're the boss, we give you great power. We recommend you do this if you need to get in and run things and not get jammed up, by the workload manager. But of course, great power, great responsibility. If you're bypassing the workload manager, you want to be cognizant of what you're running because you do damage if you run massive jobs when you're bypassing. Other nuts and bolts, I'm going to spare the details, but if the question arises, how does this adaptive workload management stuff fit in with the existing workload manager? The answer is really that we've done it in the same framework. We've done it seamlessly such that all the concepts we had, service classes, workloads, we're all still using the same concepts. So the Adaptive Workload Manager is really, in a way, abstracting up a layer from what you had been working with if you had used workload management before. So we're still working in workloads and service classes. We've just automated a lot of the lower level configuration of subclasses and work action sets that you don't need to worry about those. And then we've introduced the idea of resource share attributes on the service classes to allow you to do those resource-based configurations instead of trying to manage things with concurrency limits. So last but not least, let me spend a couple of minutes just talking about monitoring and tuning the Adaptive Workload Manager. And the fortunate thing I would say is that, as you might expect, the goal of the Adaptive Workload Manager is you do not need to do, we're trying to eliminate tuning. So it's a heck of a lot simpler than the manual limit-based configuration. But I want to call out a couple of things. And this kind of this will lead into the couple of monitoring examples I will leave you with as well. So I kind of covered this a bunch of times, but the resources that the mission control is looking at and managing around are our sort memory and the number of threads in the system. So what you're really looking at when you're monitoring or tuning is the sort memory configuration, if you're going to tune. Definitely you will be monitoring sort memory in our interfaces that report that information, and the number of threads. So sort memory is what you would expect. You've configured the amount of sort memory in the database. That configuration helps determine how much sort memory queries consume, and we manage based on that. On the agent side, it's really the degree you're setting for parallelism that influences how many threads how many ways a job is going to parallelize when it comes into the system. And we have a configuration parameter on the database called the agent load target. Really what that agent load target is saying how many threads do I want to allow to run against each of my CPU cores before I want to start throttling things so that I don't overload the system. And that number is basically the number of threads per core that we want to run. And if you look at a system like a warehouse system with SMP parallelism enabled, you set your default degree to any. That means the query is going to parallelize across all the cores. WLM agent load target in that scenario almost reduces to a sort of global concurrency limit. And I hate to characterize it that way because it's not a fixed limit in the sense of the concurrency thresholds. It's more of a fail-safe to say, at a certain point, I don't want my run queues on my CPUs, I don't want to have more than 50 threads per core running at a time. So that means for very heavy jobs, if we go above 50, I would rather throttle than keep going. And the idea here is that you probably want this to be set reasonably generously, and it's kind of a catch-all just to prevent the system from being overloaded. It doesn't have to be a precise, super precise value. So just before I run out of time, and so that we have time for questions if we've got any, just want to mention a couple of things. So there's not a lot to mention on tuning. I do want to say a few words around this WLM agent load target configuration parameter, because it is the one thing, I would say if there's anything that you sometimes have to tune on the Adaptive Workload Manager, it's this parameter. And it's particularly on systems that are a bit on the smaller side, because sometimes our defaults are a little bit conservative on this. So the thing you want to look at, the reason you might want to tune this parameter would be in a situation where the default was relatively low. Let's say it's only in the range of 10 to 20, and because the system's smaller, and when you're running the system, you see that the workload manager is queuing. There's enough memory that you could accommodate more jobs, but you're not liking the profile of your CPU consumption. CPU isn't as high as you'd like. It looks like you're not saturating the system. That would be an indication you might want to bump up this parameter. And you don't have to do it particularly precisely. If your system has a value of 12 and you don't like what you see, you do something like bump it up to 18, bump it up to 24, see if that gets you where you want. You're not going to cause, the only thing that's going to happen if you overconfigure this is that we're going to load the CPUs more heavily. More likely what's going to happen is you will hit memory constraints and we'll start queuing based on memory. And typically that is the kind of a one-time thing you sometimes have to do on a system. I've never seen a case where we wanted to decrease the agent load target unless it had been set manually to some high value, but the inverse scenario would be true too. If you see a case where you've got a massively concurrent workload, you're not memory constrained, or by the time you become memory constrained, the CPU run queues are excessively loaded and the system's dragging, then you could consider reining this in a little bit. Otherwise, that's typically the only tuning we do on the base system for Adaptive Workload Management. I will mention the sort configuration just because it implicitly affects the workload manager. So your SC share, the overall sort you have on your database, is what's going to determine how many jobs the workload manager can schedule concurrently, because that's the pool we're working with. The ratio of the sort heap. So the sort heap controls how much memory individual operators in a query can consume. And that indirectly affects the total memory a query an individual query is allowed to consume. So in the context of the Adaptive Workload Manager, what that means is if you raise the sort heap relative to the overall sort memory, individual queries can consume more memory, and it's going to mean implicitly that we can't run as many of them at the same time. Conversely, if you decrease the sort heap relative to your overall sort memory, it means less memory per query, potentially more spilling, but we're going to be able to put more jobs in at the same time. So typically don't do this type of tuning with the Adaptive Workload Manager, but I just want to call it out because it's something you can do. Probably the most common memory configuration that I've seen working with customers is if a customer is maxing out their system and they're running heavy concurrency, the memory is not exhausted. The memory is fully utilized, and we're queuing to stay within that. And you still want more concurrency. And it's not a matter of tuning the workload to be more efficient. It's just that you want more out of your system. A common thing that we sometimes do is trade off a bit of buffer pool memory for more sort memory, particularly in the column store configurations, just to give you a bit more working memory to allow a little bit more concurrency. It's often a good trade-off, and we're not talking about a major shift here. We're talking more like moving from a 50-50 division to a 60-40 division. But for those who are more into the nuts and bolts of administering the system, I just want to mention that. And then I'll close off by just mentioning a couple of things about the monitoring, which is probably the Adaptive Workload Manager. Most of what you will do is not tuning and configuration. It's more monitoring and understanding if you're happy with what's going on. And it's typically around monitoring the queuing behavior. Not to say that you won't do all the other things you do on your system to measure performance and make sure things are running well. But with the Adaptive Workload Manager, you're really looking at what's running and what resources is that consuming, what's queuing and why. And you're going to do that through there's only a couple of interfaces you would typically use. So want to get database, of course. to get an overall view of the database, and we do have metrics in there like queue times, sort memory to get an overall view of what's happening. A lot of the core monitoring for adaptive workload management will come down to the query level monitoring. So monGetActivity, which is our function which shows you in-flight query information. We have metrics in there around estimated memory consumption, actual memory consumption, the degree, which are all the things you need to know to understand what the resource consumption is by queries and what's queuing and why. If you're going after this from a historical perspective or after the fact, the package cache statement interface has similar metrics, but from a view of SQL that is run in the past. So through that, you can very quickly do a ranking and see which are your heavy resource consumers if you want to just start troubleshooting the SQL. And then if you're working at the service class level, so if you're actually configuring entitlements and dividing resources, you can use our monget service superclass stats function or the event monitor if you want to capture that data historically, or our statistics event monitor, and it will give you key information like what the target resource was, and then what the average and peak utilization was over ongoing periods. The statistics in WLM are collected over a defined interval, and then you get captured on something like every 30 minutes. If that's what you set, you're getting 30-minute view, 30 minutes by 30 minutes by 30 minutes, what the resource consumption is. And of course, I'm not going to leave you without a couple of concrete examples. I'm not going to go through these in detail, but we will find a way, either through the slides or however we do it, we can get these in your hands so that you have them to try on your own. So the queries I want to show you is samples to get started. So this is a basic one, which is pulling out a summary of resource consumption on the system. So this, query is a little complicated, but all it's really doing is doing some calculations on the configuration to tell you what your overall thread and sort memory usage is based on what's available on the system. And here you can see, for example, our sort memory is up around 80% of what's available on the system. So if you start to see queuing, or you're trying to understand the constraints or the pressure points, it's sort memory in this case. More comprehensive example, which you will probably use a lot, is pulling current statements on the system. What's running, what's queued, what are they doing, what are the resource consumption? So this type of query, which is really just combining activity information from onGetActivity with a bit of session and config, is going to give you something like this. And I spend a lot of time looking at these types of queries where you can say, okay, here's what's in the system. Okay, here are 4 that are executing. I've got 1 queued. I've added some things like query cost just as an additional indicator, but the core stuff I'm looking at would be things like, okay, what is my estimated memory consumption? What's my actual memory consumption here? Here's something interesting. I've got this queued query, and the memory estimate for this guy is 75%. Well, that's certainly unusual and not so good. This is clearly it's either a wonky estimate or a wonky query, but if I'm seeing a queuing problem, that's the guy I got to look at. And everything else looks pretty good. The memory consumption is more in a reasonable range. I can see my degree. So you're kind of working, this gives you all the information you need to know to figure out what's running on the system, who's queuing and why. My last example would be one, again, the goal of the text is not for me to read it to you here. It's for you to be able to get that in your hands and use it as an example. But what this query does is it's pulling out, it's actually pulling from the event monitor table in this case. So our statistics event monitor, which we would recommend you set up if you're running the workload manager, you would get an interval-based view of the different service classes you're running, what their target entitlement is, which resource is most constrained. In this case, it's sort memory, and then what the actual percentage consumption was over this interval. So this captured 2 intervals for 2 service classes. And in the first interval, you see that service class 1 was consuming about 18%, service class 2 was consuming about 80%. So a little bit over its target entitlement, a little bit under for service class 1. And then in the second interval, things have shifted, and the first service class is consuming well over its interval, which pretty much means that the second service class ramped back on its activity and wasn't demanding that much resource. But the idea here is that, here's the interface. The first two ones I showed you are what you would look at to see what's running in the system overall, what's going on. This would be the interface to monitor your service classes to understand what's happening in them, what the resource consumption is. The other metrics in here include throughput, response time, all the stuff you would want to know about what's happening in these different domains. So we will, get you these examples so that you can use them as a reference point. To close off, just a couple of things I would sum up. So, the idea here, this is our new workload management technology in the Common SQL engine, and the idea here is really all of this is around making things more efficient and much, much simpler in terms of workload management. We want to make workload management easy. And then in terms of what's next, so what's next? So obviously we're going to extend this to the full range of DB2 configurations. We're looking to do that next year. So that would be dropping any restrictions on having run with workload analytics. We have a few specific gaps that we need to close. The CPU control that we have in DB2, which allows CPU shares and CPU limits. We only support the limits with the Adaptive Workload Manager today. We're going to drop the restriction on the shares so that you have everything works with everything. Should mention the console. I gave you a lot of hand-built SQL examples, which is great if you want to build scripts and views and do ad hoc querying of the WLM data, but we're also doing work to bring more comprehensive WLM to the console. So that will be coming out sometime next year in DMC, and you'll see a lot of the monitoring that we want to do for WLM exposed through that, so that if you don't want to, or if you don't need to, that will help you manage that support. Final thing to mention, we're making ongoing incremental efficiency improvements on the Adaptive Workload Manager internally. With each successive release, I think we've made some good improvements from earlier 11.5 container releases up to 11.4 and 11.5. The benefits there will start to hit diminishing returns since we've squeezed most of the efficiency out of there. But those things won't necessarily be announced as features because they're internal things. But we are, based on field experiences, smoothing out all the rough edges and gaining efficiency as we go. So that's what I had. Martin, I don't know. Do you take questions on the session at this point?
I did. We had a rather small audience, and sometimes if a topic is well explained, we also don't have an awful lot of people asking questions. So I'm fine. Today our queue is empty. So good job. There's a lot of stuff there. I used to work on the workload manager on on ZOS, the operating system, back in the day, so to speak, before I got into DB2. And it's interesting watching the evolvement of goal mode, what they called goal mode on the mainframe, to what you folks have had to do for the workload manager for DB2. I've always found that an interesting parallel. I do have one last thing I need to do, which is to ask the people, did they learn anything today? So I've got the questionnaire up there. Give people a little bit of time to answer that. It's also a little into the lunch hour, so maybe we won't get an answer. It looks like we have our answer. So I'm going to close that off and share that result. And 100% of our audience learned something, which is absolutely fantastic. That's the number we'd like to see. And with that, I'll put that away. I'll cue our famous show music. And I'll turn that up. And I'll thank you once again for doing a great job. And we'll see you in a couple of weeks for the DB2 ZOS version of the DB2 Night Show with Dan Luxtetich. And following that, our next show on machine learning and AI from the IBM lab in December. All the best, everyone. Have a great weekend. Happy Thanksgiving to those celebrating. And be safe out there. So thanks and bye-bye. Thanks again, Dave. Bye-bye.
Thanks a lot, Martin. It was fun.